Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the moon before, it was the first time a rock from the moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the moon's formation around 4.5 billion years ago. On the far side of the moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts. The moon is rusting, and chances are it's happening because of Earth. You'd say that since they're more than 230,000 miles apart, they can hardly directly influence each other in such a way, but they do actually have a special connection. The moon affects our home planet as well, and you can see it while observing ocean tides. As Earth rotates, the moon's gravitational force pulls the water on the nearest side of Earth. It creates a bulge. At the same time, another bulge forms on the opposite side because our planet rotates and it causes a centrifugal force. And then, the planet continues to rotate underneath these bulges, which is why we have 2 low and 2 high tides every day. Plus, the moon wobbles every now and then, tilts more or less, and causes changes in ocean tides. And in return, Earth's atmosphere is making our satellite rusty. Rust is that reddish substance you see on old gates or nails. Oh, and you know Vermilion Cliffs and the Grand Canyon? They also have that specific red color, thanks to rusty iron in the rocks. It forms when iron reacts with oxygen and water. Rust is common even on Mars. The planet's trademark color comes from the rust that's been there for a very long time. That's how the red planet got its nickname in the first place. Normally, you wouldn't say the moon is a place that would rust that easily since it's dry and doesn't really have an atmosphere. But a spacecraft studied the moon back in 2008 and detected spectra, wavelengths of light, that were reflecting off different surfaces of the moon. That's why it could analyze the lunar surface better. The data it brought showed that the lunar poles had different compositions than the rest of the moon. They had rocks that contained a lot of hematite. That's a specific type of iron oxide, or simply rust. No one expected that because there shouldn't be so much rust on the moon, considering the conditions there. But we know that there's some water up there on the surface of our satellite. That's why a few new theories popped out about different materials the moon could be hiding. It's possible that they formed because water had reacted with the rocks. For iron to get this rusty hue, it needs something we call an oxidizer. That's a molecule that removes electrons from materials like iron, such as oxygen. But the solar wind keeps hitting the moon all the time, and it brings hydrogen with it. And hydrogen has the opposite effect. It gives electrons to other molecules. Earth has its shield from the solar wind. It's our magnetic field. But the moon doesn't have such protection, and because of that, rust shouldn't be able to form on its surface. But this process still happens, and it could be Earth's fault. The moon itself doesn't have an atmosphere that could provide enough oxygen for iron to rust. But apparently, our planet is generous enough to donate some of its own atmosphere. The oxygen from our atmosphere travels all the way to the moon, following something called magnetotail. That's a long extension of Earth's magnetic field, which can reach the near side of the moon. That's exactly where most of the hematite was found. And during a full moon, the magnetotail blocks 99% of the solar wind, which would normally influence the moon more. It's like there's a temporary curtain over its surface, which gives enough time for rust to form. But there's still one important thing necessary for the appearance of rust: water. It's not like you can find water that easily if you decide to take a walk across the moon. Most of it is frozen and hidden in areas that always remain in cold shadows. Those spots are far away from where most of the hematite was discovered, so it's hard to tell how the water got there. But there's an interesting idea. All those dust particles that hit the moon might be freeing free molecules of water that are locked in the surface layer of the satellite. This is how water ends up mixed with iron. We don't know exactly what these dust particles consist of. They might be carrying some water too. As they hit the lunar surface, this might create heat, which boosts the oxidation process, and more rust forms. So, our planet does certain things that change the moon, but humans do the same. A probe that landed on the lunar surface back in 1959 was the first human-made object that touched the moon. That's also when we started altering the moon in unpredictable ways. Scientists call this the lunar Anthropocene. It's like an analogy with Earth's Anthropocene, a period when human activity made an impact on the planet. It's not like we can choose a certain starting point when such an activity began. But we now know that things we have done over the history of our existence have really changed the environment of our home planet. We don't have any people living on the moon yet, but we've already left some traces there. After humans first came to the moon, we've had many missions there. We left some landers and flags, moved lunar soil, brought golf balls, scientific equipment, and even some human waste. Plans for the future? Send more missions up there and even potentially create an infrastructure where some of us could live, study the moon's resources, and send them back to Earth. That's why it's important to talk about the lunar Anthropocene to remind ourselves we have to be responsible and take care of our heritage. Many people are confused about why we sometimes see the moon during the day. Some even believe it's something new that didn't happen before, especially after they started sharing a low-res picture of what looks like a full moon in the middle of the day. Some have pretty unusual ideas that the sun isn't the same color as it was before either. Allegedly, it used to be more yellow. The sun hasn't changed its color. It's still blue-green. But it's possible that we saw it as more yellow when we were younger because before, pollution wasn't as bad. And when it comes to the moon, we can see it both at night and during the day. It's brighter at night because there's no light coming from the sun. But it's not like it goes anywhere during the day. It's still there, but we just don't see it during the new moon phase. That lasts a couple of days, and during that period, the moon comes pretty close to the sun. The scattered light coming from the sun makes our satellite less visible to us. Speaking of the moon phases, they're easy to recognize when you know what to pay attention to. First, there's the black moon, which can mean a couple of things. One definition says that it occurs when we have 2 new moons in a month. Another one claims that the black moon happens when there's no new moon in a month, and that only happens in February. A blue moon is not called that because of the color. It's the 3rd full moon in a season that has 4 full moons. And a supermoon occurs when a full moon coincides with the moon's closest approach to Earth in its elliptical orbit. That's why it looks bigger than usual. Sometimes you can look up to the night sky and see an eerily red sphere up there. It's not about signs that tell us that the end of the world is coming or that werewolves are roaming around. But yep, blood moon is a good inspiration for stories like that. In reality, it's just an astronomical event when our planet casts a reddish shadow on the moon. And that happens when Earth comes between the moon and the sun, which is called a total lunar eclipse. Earth's little companion catches some red light coming from our atmosphere, and that's why you see that specific color. You might think high-tech telescopes let us see every inch of the moon, but that's not true. At our satellite's south pole lie giant craters untouched by sunlight for eons, stuck in pitch black, colder than Pluto, and almost impossible to explore. However, maybe we have to if we want to explore space. Because the darkness hides some must-have resources that will make life and long-distance travel in space possible. Yes, we're talking about water locked up as tiny crystals in the lunar soil. Now, water in space is always good news. You've probably heard that scientists are also obsessed with finding it on Mars. If the red planet has any type of water below its surface, it raises the exciting possibility that life might have existed there. Even microbes would be the biggest discovery in human history. That's why rovers are poking around Martian craters and drilling into the soil like some very dedicated space gardeners. But as incredible as water on Mars would be, water on the moon might be even more valuable to us in the short term. The reasons are simple. The distance and the gravity of the moon. We can reach our satellite in 3 days. That's almost nothing. It takes at least 7 days to reach New York from London via a cruise ship. But more important than the length of the trip is the possibility of using the moon as a pit stop. Stop, refuel, and relaunch so we can resume exploration. The gravity on the moon is only 1/6 as strong as Earth's. That's not just useful for endlessly entertaining yourself by jumping around. This difference means that launching rockets from our satellite is much easier compared to launching them from Earth, which requires a tremendous amount of fuel just to break free from the atmosphere. For example, the Saturn V rocket, which took astronauts to the moon during the Apollo missions, was made up of more than 90% fuel just to get off the ground. On the moon, however, it's much easier to launch a rocket. That means that we could carry heavier loads with less fuel. It's like being able to take a bigger suitcase on your trip. If we can find and use ice on the moon to create rocket fuel, it would turn our satellite into a practical and affordable stop for exploring the solar system. Not to mention that by applying some basic chemistry, we could extract oxygen from water and use it for breathing or rocket engines. Also, astronauts would need water to drink and grow crops on the lunar base. So, what do we know about the latest discoveries? For a long time, scientists thought the moon was completely dry. But in 2009, NASA basically crashed a rocket into a crater. It caused an explosion of ice and vapor, like fireworks, and finally confirmed that the moon had some kind of water. But how much? Well, enough to matter. The data suggests there could be hundreds of millions of tons of water ice locked up in the moon's polar regions. Some estimates roughly say 1.3 trillion pounds. That's about the same weight as 460 million cars. Not exactly lakes, but still a lot. And there still could be more. This water could also contribute to uncovering cool scientific secrets. The ice is ancient, which makes it like a time capsule from the early days of the solar system. Studying those frozen molecules might tell us not only how water got to the moon, but also how it appeared on Earth. Anyway, what's all that water doing on the moon? How did it get there? Scientists assume that some of it probably hitched a ride on comets and asteroids billions of years ago. Many of those space rocks carried ice, and some of that water ended up in the polar regions. Another source could be the way solar wind interacts with the lunar surface. In any case, however this ice appeared on the moon, the real trick is where it ended up, inside its polar craters. And while we can find the ice not only in the craters at the South Pole, that's where the largest, most stable reserves are believed to be. Some of those craters are enormous. One of the most famous is called the Shackleton crater, and it's over 13 miles wide and more than 2 miles deep. That's almost twice as deep as the Grand Canyon. The moon barely tilts on its axis, only about 1 degree, so the sun never peaks over the rims of those deep polar pits. The temperatures dip to around -400 degrees Fahrenheit there. Any water or chemicals trapped in that frozen dirt just stay there, locked away like in a freezer. Something really cool is that at the South Pole, you have parts that are stuck in the perpetual darkness, but some nearby mountain ridges get almost non-stop sunlight. Scientists call them the peaks of eternal light. They are perfect for setting up solar panels, while still being close enough to access the icy treasures hidden below. The poles of the moon are the only places in our solar system we know of where perpetual day and night exist side by side. But the eternal night isn't just fascinating, it's dangerous. The terrain out there is absolutely unforgiving. We can't even simulate something like that on Earth. We don't even know what it looks like from the inside. It's worse than exploring the northernmost part of Antarctica while wearing a blindfold. So now that we know this, is that potential water even obtainable? That question is probably worth several trillions of dollars. Yes, there's water over there, but getting to it won't be like scooping ice cream from a bowl. What we're really talking about are microscopic ice crystals mixed into lunar dust. To make use of it, machines would need to dig and heat up the soil, then capture the vapor before it escapes back into space. And then there's freezing. Even assuming a human or rover could safely reach the bottom of a crater, it'd be almost impossible to navigate. Batteries and equipment probably wouldn't last, and it's impossible to use solar panels or electronics down there. They'd freeze in minutes. However, NASA's Lunar Reconnaissance Orbiter uses all kinds of radars and sensors to sniff out what the crater looks like inside. And now there's an even sharper tool, Shadow Cam. A camera so sensitive it can capture details in light 100 times dimmer than what our eyes can see. Basically, the ultimate night vision device. With it, we can finally map those pits without even setting foot there. That's why engineers are thinking up all sorts of clever solutions. Some concepts involve nuclear-powered rovers with headlights strong enough to carve through the dark. Others want robots that rappel down crater walls or hop across the floor like pogo sticks. There are even ideas for drills that could melt frozen soil and trap water vapor like condensation on a cold soda can. The silver lining is that this water isn't going anywhere. Until we improve our technology, the supply will wait for us. That being said, space agencies are already making advancements. In fact, more than half a dozen new missions are lined up over the next few years. NASA's Artemis program is getting ready to send astronauts back around the moon and then down to the South Pole. China's Chang'e 7 is planning to check out those dark craters. And private companies like Firefly and Blue Origin are gearing up to deliver equipment and experiments. Now, here's a bonus, lesser-known fun fact. The moon smells. When Apollo astronauts brought lunar dust into their landers, it mixed with the oxygen inside and ended up smelling pretty strong. They said it was like burnt gunpowder or fireworks. Lunar dust has nothing to do with gunpowder, but its particles are highly reactive. After sitting in space for billions of years, they reacted instantly with oxygen in the cabin, creating that smoky odor. Future explorers are definitely going to notice that smell too, since lunar dust tends to stick to everything. Let's hope that, aside from everything else, scientists will work out air fresheners for the moon base.
This catapult-like system on the moon might bring us limitless energy. It's a launch system concept that was recently proposed by the Chinese scientists. It would work like a hammer throw, spinning a launch arm that flings objects. This arm is supposed to be about 165 feet long. It will accelerate until it reaches the moon's escape velocity, and then whoosh, the capsule is sent into space. This crazy idea will cost around $18 billion. Ooh, pricey. But trust me, it's totally going to be worth it. The system would be powered by solar panels and nuclear energy. It could also recover more than 70% of the energy used after each launch. The moon has a very weak gravity. There's also barely any atmosphere, so the air doesn't weigh you down. This makes it so much easier to launch stuff there. But why do we even need this? The main purpose is to transport helium-3. It's a really cool isotope of helium, and one of the most insane things about it is that it could become fuel for nuclear fission. This is the same process that happens in stars, including our Sun. If we manage to recreate nuclear fusion here, on Earth, we can make it a clean and basically limitless source of energy for power plants. But helium-3 is super rare on Earth. We can sometimes find it in volcanic rock formations on the ocean floor. That's because it's a product of another rare element called tritium, the element we usually make in nuclear reactors and put in cool stuff like glow-in-the-dark paint. But the catch of tritium is that it takes forever to decay and turn into helium-3. Now, there's a bunch of helium-3 on the moon, around 1 million tons. Just 20 tons of helium-3 could meet China's yearly electricity needs. In fact, lunar soil has enough helium-3 to power the entire world for over 1,000 years. But why is there so much of helium-3 on the moon and barely none on our planet? Well, that's because helium-3 comes from the sun and travels in solar winds. Solar winds are like streams of dangerous particles. They're super radioactive. Our planet's thick atmosphere and magnetic field serve as a shield for us. They almost fully protect us from those particles. But, unfortunately, they also prevent the good stuff like helium-3 from getting here. The moon's atmospheric shields are super thin though, so it's under a constant shower of solar winds. So, helium-3 accumulated there over billions of years, and now it's just scattered around there. But mining it and bringing back to Earth is no easy feat. It's super expensive. Just think about it. Rockets need tons of fuel to break free from gravity. Every single bolt and screw on the spacecraft must be engineered to survive extreme conditions, like radiation. Not to mention, you need a team of rocket scientists, literally working around the clock to make sure nothing goes wrong. You can't call a repair guy if something breaks on the moon. So generally, it costs about $500,000 to send 1 pound of payload to our satellite. That's based on estimates from NASA. To get some idea, let's calculate how much it would cost to send an apple to the moon. A typical apple weighs about 0.4 pounds, so that funny mission would be at least $200,000. Now, for comparison, the Chinese launch system weighs around 80 tons. Another problem is that the lunar surface is pretty harsh on the equipment, like the freakish lunar dust, for example. You might recall this small thing that happened in the 60s called the moon landings. But when the Apollo astronauts came back from the moon, they found something weird was happening to them. Their throats were sore and their eyes watered. Luckily, it wasn't some scary moon sickness. Turns out, there's a lot of lunar dust clinging to their spacesuits. This dust seems harmless, but it's made up of sharp and abrasive particles, much smaller than a human hair, yet sharp like glass. It contains silicate, a thing that can cause severe lung problems on Earth and is a common issue for miners. So it caused a lunar hay fever. At least that's how NASA astronaut Harrison Schmitt called it. All 12 astronauts who walked on the moon were then sneezing and experiencing nasal congestion. Sometimes it took days to fade away. The dust even got inside their spacecraft, smelling like burnt gunpowder. This nasty stuff can be harmful to both humans and equipment. It managed to damage spacesuit boots and even ruin the seals on the containers used to bring back samples during the Apollo missions. As we mentioned, they're glass-sharp and jagged, so they start scratching, grinding, and wearing down any surfaces they come in contact with. They don't care if it's metal, glass, or humans. And since there's so much dust, this causes equipment to malfunction and fail quite quickly. And that's just one of the possible hurdles with lunar missions. So scientists really need to come up with some weird ideas to get that precious helium-3. The Chinese scientist project looks like a weird sci-fi invention, but it's a cost-effective way to transport materials back to us. It could throw stuff to Earth twice a day, and it would be 90% cheaper than current methods. Since it only needs electricity and no fuel, the system would be small and easy to set up. Besides the beloved helium-3, this catapult would also help advance technologies in space mining and heavy launch vehicles. No lunar dust scares this thing. It should last for at least 20 years. It would need to be transported to the moon using China's super heavy lift rocket. But the idea is far from new. There was a novel called The Moon is a Harsh Mistress by Robert A. Heinlein. In the story, there's a lunar colony that uses an electromagnetic catapult to send weed and water ice back to Earth. It gets quite wild when the colonists, known as loonies, eventually take control of this catapult. They threaten to launch rocks at Earth unless their colony is recognized as an independent world. Sounds kind of funny, but a large rock, if thrown at us from the moon, could wipe out a city. The damage would be like from a meteorite strike, with fires, houses destroyed, and worse. But scientists have been talking about this catapult idea for a while. For decades, they were trying to find a way to use electromagnetic systems to send resources from the moon to Earth. There are also some challenges. For example, scientists forgot to mention how exactly helium-3 would be extracted from the lunar soil. Installing this launch system on the moon's rugged surface would be difficult as well. Also, they would need to make sure that the system remains stable at high speeds and that it could withstand the moon's extreme temperature changes, cosmic rays, and intense solar radiation. So, it would take some time to develop. China hopes to have the key components of the system ready by 2030. The full-scale operations might start by 2045. China has tons of plans for the moon. For example, they want to build a research station at its south pole by 2035. But China's not the only one in this space race. Considering that NASA plans to send humans on Mars by that time, oh boy, the 2030s will be a crazy decade for space exploration. There's also an American startup that's part of the lunar economy. The ones that plan to land astronauts on the moon have people actually living on our satellite in a decade or two. One of the goals of this colony is to boost economic growth and create new jobs. Most of them will likely involve some mining activities. And if there'd be 2 space colonies, well, they'll have to figure something out.
About a century ago, people envisioned the 21st century as a time filled with quirky inventions. They weren't far off the mark. We're now one step closer to establishing an actual settlement on the moon. Before we can create a new home up, we need to find a way to stay connected, beyond just transportation and shipping. Being able to send a simple text, even something as casual as, "Hey, how are you?" is essential. We can't move to the moon if we're cut off from Earth. Let me spill some tea. A lunar 4G network is currently being developed. The company leading this initiative is none other than Nokia's Bell Labs. The company, bought by the world-famous Finnish company that started out as a paper mill in the 19th century and later ventured into the cell phone industry, creating iconic devices long before Apple launched its first phone. Once the network is completed, it will be loaded onto a lander, deployed, and connected using specialized radio equipment. But don't think this is just a fun experiment. It has significant purposes. The Lunar Outpost rover, one of the vehicles involved in this mission, will thoroughly explore an area known as the Shackleton Connecting Ridge. Another rover, the Micronova, will investigate a lunar crater in search of ice. When they discover ice and capture images, this information will be first transmitted to the lander and then relayed to Earth, an unprecedented achievement in history. Moreover, the importance of a reliable phone connection cannot be overstated. Currently, astronauts communicate via radio. But NASA aims to establish a lunar communication system capable of supporting high-resolution video. Effective communication during space missions is as crucial as food and water, and with this new lunar 4G technology, video calls on the moon could soon become a reality. Plus, thanks to lunar 4G, we'll be able to track how the endangered species sent to the moon are doing. Oh, sorry, I completely forgot to mention something important. As more species edge closer to extinction today, scientists are collecting samples from animals, plants, and other organisms to store in biorepositories around the globe. Unfortunately, the conditions on Earth are far from ideal for these modern-day Noah's Arks. Hence, the decision to build 1 or 2 vaults on the moon makes perfect sense. On the moon, there's a permanently shadowed region at its south pole. It may seem like a fortunate coincidence, but some lunar craters may meet the criterion of temperature, -320 degrees Fahrenheit, which is precisely what we need for long-term self-storage. Initially, the plan was to construct the vault in lava tubes that run beneath the moon's surface, but that would have posed significant risks. This design requires a special solar-powered cooling system, and any accidental loss of power could be catastrophic, resulting in the destruction of all the samples. However, if we built it in a forever frozen shadowed area, the vault wouldn't need any energy or human maintenance. Bingo! It sounds almost too good to be true, and indeed there are several complications. For instance, dust is an omnipresent issue on the moon, infiltrating everything. If the storage requires seals, a dust mitigation system must be developed, which has not yet been created. So for now, it remains a theoretical concept rather than a practical solution.
40, 50 feet, why don't you turn around and let them get a view from there. And
I know you want to learn about real things, not just concepts. Here's something real for you. The moon is full of human waste, carefully packed into bags. According to estimates, there are around 96 of these bags you'd probably prefer to never open. But you never know what exactly is hidden inside. It could be any product of the human body out there. So, if we ever make it to the moon and you accidentally stumble upon a mysterious bag, my advice is to resist the urge to open it. Instead, you can hand it over to scientists. They say they're eager to get their hands on them. Humans are incredible, in a rather unfortunate way. We haven't even established a proper settlement on the moon yet. but there's already around 200 tons of junk scattered about. It piles up there as if it were a teenager's room rather than a celestial body. Alongside those rather unappealing human waste bags, you'll also find cameras, drills, towels, brushes, rakes, a multitude of other technical items, and, surprisingly, a falcon's feather. I'll explain that in a moment. At the end of Apollo 15's final moonwalk, David Scott pulled out a falcon's feather and a hammer to demonstrate Galileo's theory that in the absence of air resistance, different objects fall at the same rate. Amidst all that junk, there's an actual piece of art, so we could say that the moon, if it doesn't have the very first art museum, at least boasts a small exhibition. The crew of Apollo 15 took a 3.5-inch tall aluminum figure to the moon. Created by a Belgian artist, it's called the Fallen Astronaut, and it was laid on its side with a plaque listing the names of astronauts and cosmonauts who contributed to exploration. But the list of odd objects on the moon doesn't end there. If you ever find yourself in need of cash, you can find it on the moon, since a stack of $2 bills was simply forgotten there. Yep, a lot of material has been collected since 1969, when humans first stepped on the moon.
It's one small step for man, one giant leap for mankind.
Our natural satellite was first seen in a telescope in 1609. But what about its true age? To understand that, we need to start with how the moon first formed. Back in the mid-80s, a conference in Hawaii brought together a bunch of scientists to figure out where the moon came from. They came up with a pretty cool idea. The moon probably formed with the stuff that our planet Earth donated. Picture this. A Mars-sized object crashed into the early Earth, flinging molten materials into space, which eventually came together to become the moon we see today. This theory clears up a lot of mysteries. For instance, it used to baffle folks why the moon has such a small iron core. The answer is simple. It formed from Earth's outer layer, which isn't rich in iron. And that pale crust of the moon? It's just minerals that floated to the top when the molten moon cooled down. At first, the moon was super close to Earth, but it's been slowly drifting away at about 2 inches a year, even while you're watching this video. Figuring out when this all went down, though, is a bit tricky. The Apollo astronauts brought back a bunch of moon rocks, which helped scientists estimate their ages. The oldest ones are around 4.35 billion years old, which is about 200 million years after the solar system kicked off. So, here's the thing. There's no exact date for when the moon formed, but there are several interesting theories. One idea is that the age of these rocks could mean the moon is around 4.35 billion years old. But some scientists who look at how planets form think that most of the material in the early solar system came together way before that 200 million year mark. They argue that a big impact that created the moon happening that late seems pretty unlikely, which means the moon could actually be older than 3.5 billion years. Another interesting thought is that the moon might have gone through some serious heating events as it moved away from Earth. This is similar to what happens on Io, one of Jupiter's supervolcanic moons. The gravitational pull from a bigger body can stretch and compress a smaller one, generating heat, like when you squeeze a rubber ball. The rocks on both Io and the moon warm up this way. Rocks have radioactive elements that act like internal clocks, helping scientists figure out their ages. The catch is, if the moon heats up too much, it resets those clocks and only starts keeping time again once it cools down. So those rocks that are about 4.35 billion years old might not actually mark the moon's birthday. They could just indicate a time of tidal heating. This suggests, once again, that the moon had to have formed even earlier than that.
How about playing golf? Not on Earth, but on the moon. Let's journey back to a time 50 years ago when one astronaut turned the lunar surface into the most unusual golf course ever. Any golfer will tell you how tricky it is to avoid sand traps, but picture Alan Shepard, a NASA astronaut dealing with an entire surface that feels like super fine powder. During the Apollo 14 mission, he took a break to showcase some spacey golf skills for everyone watching from Earth. After his first shot, he excitedly made another. For him, it seemed the ball went forever and ever. Let's dial back to reality for a moment. Thanks to the research by the United States Golf Association, or USGA, we've got some numbers. They found that Allen's first moon ball traveled 24 yards, and his second stretched for 40 yards. Now, how does that compare to the average golf shots back here? In regular gravity, one usually swings to about 216 yards. Just goes to show, while we've upgraded our golf game on Earth with tech and training, the moon's low-gravity playground is a different environment altogether. Now let's give Allen some props. Moon golf? Not as simple as you might think. His club wasn't one from your local sports store, it was a makeshift one. A moon sample collector with a club head stuck to it. Add to that the bulky spacesuit he had on. Imagine trying to swing wearing an outfit that's as stiff as cardboard. With all that gear, Allen could only muster a one-handed swing. Care to have a similar experience? Well, you might not be able to play golf on the moon anytime soon, but you can give it a shot underwater. Some say the conditions are similar. Here's where it gets even more interesting. The USGA didn't just take Allen's word on where the balls landed. They wanted to investigate. For starters, they used ultra-clear footage of the Apollo 14 mission. They also used some sharp images from NASA's special moon camera, launched in 2009. Using this imagery, they mapped out the journey of those two golf balls. Allen loved his unique golf club so much, he wanted to bring it back home. No big deal, right? Well, you see, in those days, astronauts would leave behind unnecessary items to make space for moon rocks. But not this club. So during the 70s, this interstellar golf club found a new home at the USGA Museum in New Jersey. Unlike regular golf clubs, this one had a twist. It was crafted from aluminum and Teflon. It was built to fold and fit snugly within the tight spaces of the lunar lander. How did this whole moon golf idea even pop up? Well, in 1970, golf legend Bob Hope paid a visit to NASA. Inspired by Hope's love for golf, an idea came into Shepard's head: moon golf. To turn his dream into reality, he collaborated with a golf professional and NASA's tech specialists. Together, they crafted a club that met NASA's strict safety norms. But hey, Allen didn't want this to be just a surprise stunt. Remember, traveling to the moon required very strict protocols. They couldn't just randomly have a picnic up there, you know? So, Allen made sure NASA officials agreed with this impromptu game of golf. They were initially skeptical, but eventually gave the green light after Allen passionately laid out his plan. He also promised he'd start playing if everything went smoothly on the mission. Determined to make it perfect, Allen prepped like a champ. The story goes that he'd put on his hefty spacesuit and sneak off to secret spots so he could practice. Decades later, he'd still be reflecting on his lunar escapade. He was the only golfer to ever swing on the moon. It's not just golf balls that astronauts left behind on their trips. There were actually a lot of objects left on the moon between 1969 and 1972, the year of the last moon landing. Each time you gaze up at the moon, remember that there's a cute family photo up there, some huge science gadgets, a small statue, a bunch of, well, human waste bags, and yes, some American flags. Years have passed by, and yes, technically those items are still hanging out there, though they've probably seen better days because of the harsh conditions on the moon. Some items had a special place in the astronauts' hearts and were meant to stay on the moon. But hey, leaving some stuff behind also meant they could bring back moon samples. You know the feeling. It's like when you need to make room in your suitcase for souvenirs when you're finishing a vacation. Does NASA have a complete list of things they left on the moon? Well, not really. In fact, one team tried to create a record of some of the items and reached an amazing list of 106 left there from the Apollo 11 mission alone. And that's not counting Neil Armstrong and Buzz Aldrin's famous footprints. The largest items at each landing site were mostly the sciencey stuff, like pieces of their lunar module and experiments to study the moon in depth. Then there were some beautiful tokens, like Apollo 11's plaque and a special disc with messages from leaders around the world. Some say the astronauts also took medals to remember some heroic cosmonauts, and they even left a gold olive branch, an age-old symbol of peace. Now, later moon missions had a little more fun, like Alan Shepard did with his golf game. But the award for the most heartwarming moment goes to Charlie Duke. During the Apollo 16 mission, he left a picture of his family up there. It's like he wanted them to be a part of the adventure. Although, a heads up, those photos probably didn't age well because of the moon's high exposure to the sun's radiation. There might just be an art museum up there on our satellite too. Let me explain. There's this tiny little art piece called the Moon Museum. It's a ceramic chip about the size of your nail, and it was crafted by an artist named Forrest Myers. This tiny object showcases miniature artworks from 6 talented people. Among them are even the famous Andy Warhol, the same artist known for his iconic soup cans and celebrity portraits. Forrest Myers said he wanted his mini museum to be on the moon, but there was a problem. NASA officials weren't exactly on board with the idea. However, Myers shared with the press that he handed over this art chip to an engineer working on the Apollo 12 mission. According to Myers, this engineer secretly tucked the Moon Museum onto a leg of the lunar lander. In case you haven't figured it out yet, these lunar landers don't come back to Earth after their mission. Take this with a grain of salt though, as NASA has never confirmed this story. You might wonder, why did they leave all these things? Sometimes it was about making a statement. Other times, it was purely practical. At one point, it was mentioned that during the Apollo 11 mission, for example, a decision needed to be made. The astronauts had to quickly figure out what was essential for their trip back home. They ended up creating a cleanup spot, tossing away things they didn't need anymore. Leaving things behind on the moon isn't that different from how we leave things behind on Earth. Just like archaeologists study our ancient leftovers to learn about our ancestors. The stuff on the moon gives us insights about those incredible lunar missions. Some things they left had done their job, like the pole for the flag or the camera they used to broadcast those steps on the moon. Even the tools astronauts used to collect samples were left because they had more precious cargo to bring back – moon rocks. When it comes to the current state of all these items, scientists are not entirely sure. We do know that NASA's Moon Observer has spotted some of their shadows. They're still up there. The official gear was built to resist, so it might behave a bit better. But those personal items? They've probably seen better days.